All right, so let's take a look at page 2 here, and page 2 and 3 tend to be my favorite questions because they're really trying to poke at you guys to see how well you understand the material. Now, I want to make some kind of broad comments about these types of questions. So remember, when you take an exam, any exam, I'm not just talking about, for this particular course. Remember, really part of your job is to convince the person grading the exam that, you really know what you're talking about, right? That you've got as thorough a grasp and understanding of the material that is reasonable, right? And so the biggest problem, and it was honestly kind of a head scratcher to me, was so in the world of organic chemistry, when somebody asks you to explain something, right? They're really asking you guys, well, how does this work, right? How does this work? Why does it work? Where does it work, right? And so the best way, and one of the simplest ways, and one of the most elegant ways to explain all those are to draw a mechanism. And really, I think there are about 2 exams that people bothered to draw the mechanism. Although there were a lot of people that tried to explain the mechanism. Well, just draw it out for me, right? It doesn't say anywhere in here that you can't draw anything. It just asks you to explain it, right? And you're not limited in space to what I give you guys here, right? Use extra space. I don't care, right? Just attach your work, show what you need to, right? Now, maybe you're like, well, the directions say to do it concisely. Well, just all I'm really saying is get to the point, right? Don't sit there and fluff about and, add information that isn't relevant. Explain the observations. So whenever I ask you these types of questions, draw the mechanism, right? You guys should be able to draw the mechanism for every single question on this page here, okay? Now, I'm not going to do that here because otherwise then these videos would be, a couple hours long. But that's the other point, right? So remember, this is a take-home exam. These are designed to take longer than what it would in class, right? And I don't mean like, oh, well, it's going to take you 15 hours. That's not what I mean. What I mean is these questions are designed for you to sit down, to think about it, to come up with a response, maybe come back to that response, edit it, think about it, add to it, right? You guys have I think I gave you guys like 3 days or so to work on this. That's a lot of time, right? So whenever, and you guys are going to see these questions again, so whenever I ask you guys these questions, just sit there and stop and think about this and, really put something coherent and concise and thorough down on paper, right? Thoroughly convince me that you understand this question and that you can explain it and that you can understand it and, convince me of it is what it is, right? I know you guys are smart. I know you guys are intelligent. That's not the question. What I'm really asking is, can you guys explain what you know? Can you guys explain what you know? And so, to think about this a little bit, right, I always ask students to understand the 5 W's, right? So the who, the what, the when, right, the where, and the why, right? So these are always 5 good questions that kind of look at your answer and say, does my answer cover the who, what, when, where, and why, right? Now, maybe who in this case is a little bit ambiguous, right? We can chat about that. The what, the when, the where, and the why, okay? So let's take a look at if we can kind of find where or how we can answer all 5 of these points, okay? So maybe if I think about the who, I'm thinking about what is our substrate, right? What is getting reacted? Well, we've got an aromatic ring, we've got a bromine, and we've got a catalyst here, right? So those are the who that are involved. So part of your answer should be analyzing that, right? We have an aromatic ring. We notice that it has an alkyl group on there, right? We have a Lewis acid catalyst that is used to generate a good electrophile, right? So that's a good explanation of the who. You would come in there and you would draw your mechanism showing the formation of that electrophile. Fantastic. What is happening? well, let me change colors here, so maybe if I have to circle something, right? The what is happening? Well, this is an electrophilic aromatic substitution, right? The what is another great point at where you should draw your mechanism, because that is explaining what is happening, right? The formation of the electrophile followed by the aromatic ring attacking the electrophile, the resonance that is made as part of that mechanism, and then the reformation of the aromatic ring. Okay, so a good point for your what there is the drawing mechanism. When? Gosh, I did it again. Black this time, okay? When? Well, here I gave you guys some information about time, right? So when, in the chemistry terms, is probably something like kinetics, okay? So here we would take a look at our data and say, what is our statement? Well, our statement, what are the difference in times? Well, here we could make a statement such as, we notice that in the activated ring on top, the reaction time is about 70 minutes. The reaction time at the bottom is 400 minutes. This is a direct indication of the activation versus the deactivation of the ring because we are doing the same reaction in both cases, right? The mechanism doesn't change, and so the kinetics is based off of whether we have an activated or deactivated ring. And you could talk about what it means to be activated and deactivated at this point, okay? The where is, you guys got the where part down for the most part, right? The most common answer in this case was like, well, in the top reaction it's a para, and the bottom it's a meta. Well, that's fine. I'm glad you guys understand that. But, where do they add, right, is answered by the mechanism also, okay? Because what you should do is go through and say, in the bottom reaction, the bromine is added at the meta position, and you draw out the mechanism. And you say the reason why a deactivator such as trifluoromethane prefers to have something added at the meta position is because, as you can see from the mechanism, the positive charge is never placed on the carbon that is adjacent to the positively charged carbon. Okay? Telling me something is a para and is in the para and the meta position is just an eye exam, right? You're just saying, yep, there it is. One's in the para and one's in the meta. Why? Explain it to me. Explain that to me, okay? And then finally, the why here is kind of, maybe we kind of lump that all together with the other questions here, right? Why does it go para? Why does it go meta? When does it do that? What does time tell us about it? What happens with the mechanism? Who is getting reacted here? The aromatic ring, the electrophile, the different species, the intermediates, right? So the who, what, when, where, and why is what we're looking for here. Use the data, right? Use the data that we have to kind of start to explain things. So another common thing that I noticed is that you guys said, yep, it's 70%, so it's the major product, and it's 90%, so it's the major product. Okay, again, you guys are just looking at the numbers and telling me something, right? You're not explaining it to me, though. Okay, why would one of these have a lower yield than the other one? That's a great question, and that should be something that we can explain. Why would an activated ring have a lower yield than a deactivated ring? Isn't that interesting? Now, one argument could be that, well, one of them's reacted longer than the other, and that would be an okay statement to make. We don't have any necessarily more information about that, right? If I gave you guys some kind of graph with concentrations or something like that, then we could, make a more thorough statement, but I don't really care about that. A question should be, well, why would an activated ring have a lower yield? Well, there would be a great argument to come back and talk about. Whoops, I used the wrong size there. It'd be a great argument to come back and talk about where is the missing 30%. Okay, where is the missing 30% here? Well, we would say the other product is likely going to be the ortho, right? And we know we've got, 2 ortho positions for every one para, so that's going to decrease, right, the yield from the one on top, and you could make some argument about sterics at that point and discuss how the methyl group is not all that sterically encumbered, and likely we would have a high percentage of the ortho getting formed also, right? That would be a perfectly fine and valid statement to make, okay? So I really want you guys to sit and think about these questions. And I'm not saying you guys didn't think of that. I'm not upset at you guys. Look, let me be very honest with you guys, as I always am, as I always hope to be. At the end of the day, there's a number of you guys who are chemists. And so I'm trying to help you guys as chemists develop your storytelling ability. And what I mean by telling a story is you guys should need to be able to tell a scientific story. You guys are going to have a hypothesis, right, that you guys are going to need to back up with data, and you're going to have to tell a story based off of that, right? Being able to analyze scientific data. For the rest of you guys are like, well, I'm not a chemist, I don't care about that. Well, that's fine, but all of you guys should be working on developing your critical thinking skills, okay? Now, critical thinking is one of these things that we all put down on our resume, so to speak, and like, yeah, I'm a really good critical thinker, and I hope you guys are, right? I really hope you're developing this, but critical thinking is not, this is something that's like going to the gym, okay? You have to work at this constantly to be able to hone this, right? It's not just something that people are born with, right? And so critical thinking is difficult, right? It's difficult. You have to sit down, you have to think, you have to question yourself, you have to really understand and grasp material to come up with some kind of analysis that shows an in-depth understanding of these concepts. And that's what I'm looking for here, okay? So when you see these questions next, maybe a good place to start would be with the 5 W's. Walk through what we did here. Who is reacting, aka do we have an aromatic ring, or in the upcoming chapters we have carbonyls, right? Is it a ketone? Is there an aldehyde? Is it an ester? Is it a carboxylic acid, right? Those are good who questions, right? What is going on, right? Is it are we under acidic conditions? Are we under basic conditions? Do we have a Lewis acid? Do we have a strong acid? Do we have a weak acid? Do we have a good nucleophile? Do we have a weak nucleophile? When, right? The kinetics. Is one reaction faster than the other, right? The where, that's kind of our mechanism, right? Or where we are adding things. Okay, the why, the mechanism again. Take a look at your resonance structures. Draw them out. Explicitly describe what is happening there. Now, for some of you guys, you just listen to all that and say, that sounds like a lot of work. Yeah, I know. That's why, right? That's why I give you guys the time, right? To work through this exam. And, this is the first assignment I gave you guys, right? I'm asking you guys I'm trying to be respectful of your time, and I know I've got a lot of videos up there for lectures for you guys, and now we've got an assignment here, and just make sure you guys are taking the appropriate time to get the grade that you guys want for this course, okay? And as always, please look. I think if I can critique myself here for a little bit, and I've gotten quite a few questions and through emails, and I think I've done a pretty good job answering all those in a very timely fashion. Email me. I'm happy to work something out with you guys, right? I'm here to help you guys out, but I can't read I can't read minds, and just email and say, hey, Dr. H, I've got a problem. I just don't understand. I don't understand this, or would you mind taking a look at what I'm working on at the moment? That's just fine, okay? For these exams, if you guys, have questions about it, say, well, is this really what, he's looking for? Is this really the answer? Am I on the right track? This kind of, I'm happy to help you guys out, okay? It's a different situation. I get it, right? You guys are used to taking exams in class and all this kind of stuff, and there's different rules and everything, So, I'm here to help you guys out as much as I can, but you guys have to let me know what I can do to help you out too, is what I'm saying, okay? So, here's my assignment for you guys for next time, okay? Because I think we're about 15 minutes in, and I don't want to turn this into a 40-minute video because that's a lot to digest at once. But see if you guys can go back and come up with good who, what, when, where, and why for these next questions here, okay? All right, I'll see you guys in just a little bit in the next video then.